Okay, one of the first things I wanted to do today with you was go over the gizmo that you guys did in the previous class. There were certain parts of it I wanted to take time to explain to make sure you understood what was going on. I thought part A with the transverse waves and longitudinal waves was pretty self-explanatory, so I'm going to hop right down here to part B in wave dynamics. Okay, and I want to look first at this chart that you were supposed to fill out. You were supposed to go through and you had your amplitude, frequency, tension, and density all set at a certain thing. In part 2 here, you were supposed to be changing those, changing one at a time. And as you did that, excuse me, you should have got the following results. Increase in the amplitude did nothing to wavelength or wave speed. Increase in the frequency decreased the wavelength but did nothing to wave speed. Okay. Increasing the tension would increase both wavelength and wave speed, and increasing the density, and I do want you to pay attention to this part because I think I told you wrong during class, but you should have noticed that increasing the density of the medium caused a decrease in the wavelength, and this is the part I believe I messed up on, it caused a decrease in the speed. Okay, so as things move into denser objects, they slow down. Okay, and I think I had gotten that backwards when I was talking about it in class. Okay, so from that, we were able to move down to number 3 here, and this part I specifically want to talk about is letter C. And the question was, how is the wavelength, frequency, and wave speed related? And what you should have been able to look at and figure out is that wave speed is equal to the frequency multiplied by the wavelength. And you can see the equation there. I have it highlighted. V, velocity, or wave speed, is equal to frequency times wavelength. Remember that lambda represents wavelength. Now that equation is important because you will use it later on in this gizmo, and it also was necessary to use when answering your 5 assessment questions, which I will be going over with you here in just a few minutes. Okay. So from there, we move down to the second table, and in this, you were seeing what happened to the power if you changed amplitude, frequency, tension, or density. And you can see there in the first part, your amplitude was doubled, and that doubling of the amplitude caused an increase of power. And if you remember the equation the lady mentioned to you in the video, the 1/2 K A squared. Okay, so doubling the amplitude actually causes it to increase by a factor of 4, and that is what happened. Okay, we moved then to frequency, and you doubled your frequency. Again, you can see that the power was increased, so increasing frequency increases power. Part 3 there, we doubled the tension. We see a slight increase in power here also, and then when we doubled the density, we see also again a slight increase in power. So the question is, which factors increase the power of wave? All of them did. Whether you increased amplitude, frequency, tension, or density, you were going to increase the power. So they all are directly proportional. Well, I won't say proportional, but they directly affect the power. Increasing any of those 4 is going to increase the power of the wave. Okay, so that is something I wanted you to make sure to understand the effect that you get, or what the effect is on each of those properties on power. Okay, from that we were able to, or you should have been able to, gun down here and answer questions 6 and 7. And again, I wanted to go over these because of what I had mistakenly told you in class previously. But if we look at the first one, sound waves are longitudinal waves that can travel through air. You expect sound waves to travel faster through a low density gas or a high density gas. Okay, and justify your answer. Well, if we look at what we learned earlier, and I'm going to go all the way back up here, increasing the density caused a decrease in the speed. Okay, so again, that's why I want to point this out. So since increase in density medium causes the speed to decrease, that's what we found out earlier, sound waves should move more slowly through the higher density carbon dioxide. Okay, and if those sound waves were to enter a liquid such as water, they would slow down even more. Okay, and that is why things sound different when you are underwater than when you're above the water. Okay, and then as we move to number 7, if the frequency stays the same, then the wavelength must decrease because the speed is decreasing. Okay, because as that make contact and that friction occurs, this is going to slow down the wave. Since the frequency is not changing, it has to be the wavelength is changing, and they are directly proportional. The wavelength will decrease in the same proportion as the wave decreases. Okay. Now let's hop down to C, and we get combined waves. Combined waves is when we have a transverse wave and a longitudinal wave working together. We talked about this when we did surface waves. So I'm just going to hop down to these last 2 questions, and the 2 things that I wanted to point out and make sure that you understood was how do wavelength, wave speed, and wave power combined compare to the transverse wave with the same settings. You should have found out that wavelength and speed of the combined and transverse waves were the same. However, the power for the combined wave is twice the power of the transverse wave. So wavelength and speed stay the same, but the power is twice as much in the combined wave. Why is this? The combined wave is more powerful because you have the combined power of a transverse wave and a longitudinal wave together. Okay, so you have to add the power of those 2 individual waves to come up with the total power of the combined wave. And that's just kind of common sense there. So those are the main things I wanted you to get from doing that Gizmo, and make sure you understand that when it comes quiz time. Now, if I hop over here to your questions, then hopefully these are the things you were supposed to pick up and what we had talked about in class and through the Gizmo. Obviously, if we look here at number 1, this should have been really simple for everybody, but we can see that the wave here is moving up and down. You have a trough, a crest, and a trough. So anytime we have crest and troughs, we know that is letter A transverse wave. Okay, as we move into number 2, what is the amplitude of the wave, length of the wave? So on these 2, I'm going to move this so we can see the possible answers, but amplitude is from here to the crest, so we can see that that is 30 centimeters. So we know that's either got to be A or B, so now we need to measure wavelength. The wavelength is the distance from one crest. So here we are at 30 centimeters all the way across to the next crest. That's at 140. That's a difference then of 110. So the correct answer here should have been letter B. Okay, now when we get down to number 3, you have to pay attention to what amplitude is in a longitudinal wave. When we do amplitude in a transverse wave, it's the distance from here to here. Okay, how far is that wave moving up and down? In this case, up or down. Okay, so we would say that this has that amplitude, as we said, of 30. When we do longitudinal waves, you were supposed to pay attention to this green dot. So how far did it move to the right? How far did it move to the left as this compression moved through? Okay, so if we go from here, okay, from the center there, we can see that we are at roughly right here in the center at about 95 maybe. And then if we go up to here, there's 110. So from a 95 to 110 is 15 centimeters. Okay, and the only one here with 15 centimeters is A, so we can double check that by measuring the wavelength. So the middle of this compression is at 0. The middle of this compression is at roughly 150. So yes, it is a 15 centimeters, 150 centimeters of wavelength. Okay, Now, when we get down to number 4, this is where you are going to have to use your equation. We learned that velocity is frequency times wavelength. Okay, in this case, you are given the velocity, 335 centimeters per second. Okay, you're being asked to find frequency, so you're going to have to look at this and measure the wavelength. So if I measure the wavelength and I go right here from 60 up to 190, that is 130. So in order to find the frequency, I take the velocity or wave speed and divide by that wavelength. Okay, so if you did that correctly, you are going to end up at 2.58. So the closest answer here was 2.50 hertz. So you should have marked letter D. Again, you had to take the wave speed divided by the wavelength. Okay, and how could you increase the power of a spring? Okay, I'm going to hop back over here to your worksheet that I showed you earlier, and I'll hop right back up here to this right here. And it says, is increasing amplitude, frequency, tension, or density will increase the power of the wave. So this question went directly along with question 4 here. So obviously it is all of the above, increasing any of those, okay, along with wavelength, would increase the power of the spring. Okay, so again, that is the explanation and the things I wanted to make sure you understood from doing this gizmo. So now you'll just move on into the next part of the PowerPoint, and you're going to be going over those 2 different short little videos, and then make sure you complete the worksheet.